Now let us move on to the last module, the course which gives Introduction to Regulations. In this section, you will learn why structural regulations are essential to ensure aircraft safety and reliability. We will explore who regulates civil aircraft structures and the philosophy behind structural certification. You'll understand how structural loads and safety factors are defined, and how static strength, fatigue, durability, and pressurization testing are used to prove compliance. The module also explains damage tolerance and continued airworthiness, and shows how design, maintenance, and regulations are closely connected. Modern air travel is among the safest ways to move people, with accident rates drastically lower than decades ago, thanks to risk-based safety practices and regulatory oversight. A structural failure in flight can instantly turn a routine trip into a life-threatening emergency, so aircraft structures are designed, tested, and inspected to avoid that at all costs. In the early days of flying, structural failures such as wing cracks and metal fatigue were common, driving home the lesson that aircraft need design limits and safety margins from day one. Historical structural accidents, like the Electra wing failures, forced regulators and manufacturers to rethink design rules and introduce better structural testing and inspection standards that still shape civil aircraft today. Designing a structure only to be strong isn't enough. A safe aircraft must tolerate damage, resist fatigue, and continue flying even when tiny flaws exist. Regulations exist to translate lessons from accidents into requirements that ensure every aircraft sold and every flight taken meets the same minimum structural safety standards. Case Study 1. Early fatigue failure in the Stinson aircraft, 1945. In 1945, a Stinson passenger aircraft suffered a catastrophic structural failure when a wing spar broke in flight due to metal fatigue. The aircraft had accumulated repeated load cycles over years of operation, and tiny cracks slowly grew unnoticed until sudden failure occurred. At the time, designers did not fully understand fatigue behavior in aircraft structures. This accident highlighted that structures can fail well below their maximum strength if fatigue is ignored, leading to the introduction of safe life limits and mandatory inspections, which later became a foundation of structural regulations. Case Study 2. Lockheed Electra wing structural failures, 1959 to 1960. The Lockheed Electra turboprop experienced multiple in-flight breakups caused by wing structural failures triggered by vibration and flutter. Investigations revealed that engine and wing interactions produced unexpected dynamic loads that exceeded what the structure was designed to handle. These accidents forced manufacturers and regulators to rethink how structural loads were defined and tested. As a result, stricter structural testing, better understanding of dynamic loads, and improved certification rules were introduced, many of which still influence modern civil aircraft design. Aircraft safety isn't luck. It's engineered and regulated. Every rule comes from learning what can go wrong and making sure it doesn't happen again.